heat from 2,800 degrees C to 16,700 degrees C. We'll melt both the electrode and the parent metal and the plate being welded fused together on cooling. This is the process of welding. And type of welding consists of, as you already given in this slide, butt weld, fillet weld, deep penetration fillet weld. Welding process. Next, under welded connection, the most common types of welding processes consist of shielded metal arc welding, also known as stick welding. Wait, somebody want to join? Kali kena masuk awal, terganggu saya punya kelas. The second process is gas metal arc welding, GMAW, or metal inert gas, MIG. Next, gas tungsten arc welding, or tungsten inert gas, TIG, GTAW. And the last one, I think, flux core arc welding, or FCAW. Introduction, you need to have more, search more, like I just mentioned just now, reference book or articles. You can search in library as well online. Okay, this is type of the mentioned just now, SMAW, GMAW, FCAW, and GTAW. Okay, now look at EC3. I always mention you need to familiarize with your EC3. Beside you, bring everywhere in soft copy and hard copy as well. Can you turn to page part 18 again and again until you familiarize with it? Part 18. Part 18. Part 18 is meant for the connection design for both type, bolted and welded. Today, you can refer to both welded connection, section 4, 4.11. 4.11. Okay. Mentioned here, design of weld, the simplified method is to be introduced. The simplified method to be introduced. Next, the provision applied to weldable structural steel conforming to the standard in 4.1 and to material thickness more than 4 millimeter. You can see the highlighted red color in your slide. Material thickness must be more than 4 millimeter. This is the requirement. This is requirement. Yang baru masuk ni tolong tepat masa. Ganggu lecturer untuk bagi kuliah. Okay, syarat material thickness adalah more than 4 millimeter. And then we focus on the type of weld. Two types, which are fillet weld and butt weld. Fillet weld and butt weld. Okay, next, typical welded joint. Okay, Just now we mentioned that material thickness must be more than 4 millimeter for the welded joint, welding joint. And there are consist several types of joints, which are boot weld or boot joint, corner joint, T-joint, H-joint, and leg joint. Okay, so this is type of welding joint. Okay, next, under 4.3.2.1 up to 4, 1, 2, 3, 4, especially for the fillet weld, there are requirements as well. The number one, the angle of intersection should be in the range of 60 degree and 120 degree. Okay, next, if less than 60 degree, the weld should be considered to be a partial penetration boot weld. Itu syarat untuk fillet weld. Kalau kurang daripada 60 degree or less than 60 degree, the weld should be considered to be a partial penetration boot weld. And if more than 120 degree, the strength of the weld should be determined by testing. This is all under the items 4.3.1. 4.3.1 1 to 4. You can, if I refer to my book EC3, turn to page 38 and 39, part 1A, please. You need to familiarize the EC3. I always mention you deal with time. You deal with time. So everything in the EC3 you need to recall and you need to familiarize. Easy to you to refer it. And without any delay. Okay? Without any delay. Because you deal with time 45 minutes only per question. Okay? 45 minutes per one question. Be it in your test or in your final examination. It's around the corner. Next week will be test 2. Covered 2 topics, truss design and connection design. Both you must be answered. All question must be answered. Okay. Another 15% assessment will be assessed from your lecturers. Okay, another 15 under me, your class. This part, this part is under me, and another part is under Professor Dr. Sheikh. All right. So continue with this requirement for fillet weld. Second point is fillet weld finishing at the end or side of part should be returned continuously, full size around the corner for a distance of at least twice the length of the weld. Syarat seterusnya. Okay, next. Second type is boot weld. Mentioned about under 4.3.4.1. Page, turn to page 40, 41, and 40, 41 and 42, and so on. Okay, the first part under boot weld is a full. They mention about a full penetration boot weld is defined as a weld that has complete penetration and fusion of weld and parent metal throughout the thickness of joint. Second line or second point is partial penetration boot weld is defined as a weld that joint penetration which is less than the full thickness of the parent material. Next, intermittent boot weld should not be used. Any questions so far? Are you follow? Please respond. Anyone?
Yes.
Okay, next. Thank you. You can have a drink along this lecture. Okay, I will be introduced to you the next slide for design resistant of fillet weld. Design resistant of fillet weld. This is under 4.5.21. Turn to page 42, 42 and 43. 42 and 43 in your EC3 book. In your EC3 book. Okay, weld design. First of all, we have to know the item or the symbol. Number one is S. S is considered as or defined as leg length. This is under design resistant. We should know the leg length first, or symbol S for leg length. Next, we have to know also the effective throat thickness. Based on the figures, you can see the S leg length and the A symbol for effective throat thickness. A equivalent to 0.7 S. 0.7 S. And next requirement for A must be more than or equal to 3 mm. 3 mm. Hence, S is more or equal to 4 mm. Sorry, hence S is more than 4 mm. Okay, you can see figures there showing that number one arrow or number one stated that there is leg there, showing you leg length, showing you leg length or S symbol. Number two is the root. Number two is the root of the fillet weld. Number three, we call it face of the fillet weld. Number four is the toe of the fillet weld. And number five is the throat thickness or symbol A as shown in the figure. Can you follow? Can you understand? A little bit more. Okay, you can put a sign good if you follow, please. I cannot hear or I cannot see your response. Can you respond it? Come on, please respond. Are you follow? Are you follow? Orang sama ni, yang lain macam mana? Yang lain tidur ke? Ni saya kena wake up ni. Wake up call panggil. Macam tu supaya tidak tidur. Okay, thank you. Alright, next. Again, we should know the LE as well, or symbol for effective length of wet. You can see in the figure, LE is equivalent to L, the total length, minus 2S, 2 times lead length for both sides. That's meant for effective length of wet. Effective length of wet, LE. The symbol is LE. This is under item 4.5, 1 and 2. Next, if LE less than 230 millimeter or less than 6A, whichever is the larger, it should not be designed to carry load. It should not be designed to carry load. Okay. LE equal to L minus 2A can conservatively be taken as L minus 2S. Okay, L minus 2S can conservatively be taken as L minus 2S. All right, next. After we know about LE equal to L minus 2S or L minus 2A, we can start design for resistance. Design resistance. FW, the symbol is FWRT. FWRT. Okay, as a principle, we always know that the resistance must be more than effects, action or loading, so that FWED must be less than or equal to FL FWRT. FWRT. Now we need to calculate the FWRT equivalent to or equal to FVWD, where FVWD is meant for design shear strength of web. Design shear strength of web times A. Times A. F again. FWRD is meant for design value of web force per unit length, kilonewton per millimeter. FWED meant for design value of web force per unit length, kilonewton per millimeter. And FWRD is for design web resistance, also kilonewton per millimeter run. When we analyze, we should consider 1 millimeter length. That's why per millimeter. Next, FU is nominal ultimate tensile strength of weaker part, and beta is meant for or equal equal to 0.85 for steel grade S275, and beta is equal to 0.9 for steel grade S355. Okay, you can refer also table 4.1 for the rest of the for others value. You can refer table 4.1 in part 1.8. Turn to page 44. Turn to page 44. Okay, you can refer to the table 4.1. And also, you don't need to memorize the formula of FVWT because it's already given to you in EC3 book, part 1.8, page 44. That's equivalent to FU over Z3 divided by beta W gamma M2. Easy to calculate, FVWT. I think design is always, I told you before, it's easy when you already settle the analysis. Okay, if you settle the analysis, then you can easily follow the procedure of the design resistance, be it for the connection design and for the rest of structure members. The analysis is very important. Before you start design, you need to settle for analysis first. Okay, same goes to this particular fillet weld design resistance. Okay. Okay, then you just refer to this table for value of FU based on the steel grade and also based on the thickness. Okay. Okay, you can calculate based on the formula given in your EC3 part 1.8 for page 44 for this particular design. Okay, I leave it to you after this class. You need to practice. I'll always mention about it. You need to practice because you deal with time. You deal with time. 45 minutes per one question. Okay, you practice, you always remember that. Practice make perfect. And you can finish in the provided time time given, 45 minutes. Okay, next, common practice. Weld continue around the corner and at least twice the length of the weld, or 2 times S. Okay, means LE equivalent to L minus S. L minus S, you can refer to the item part 1.8, 4.3.2.14. You can see the figure as well given to you in the slide. What is LE, L, and S? Okay, LE is the effective length equivalent to or equal to L total length minus S. Okay, so maybe you feel it's not really understand before you start the example or you start practice. Always you need to practice, then you can consider the complete, complete, or you can understand very well. Okay, inshallah. Common practice: if the connected plate is welded longitudinally, L more than 40, where T is the thickness of the thinner plate. T is the thickness of the thinner plate. T is the thickness of the thinner plate part jointed. You can see the figure showing you the thickness of the thinner part jointed, or T, and the part of the L must be jointed, must be more than 4 times T. 4 times T. Okay. How you want to analyze this figure? Show you the solution. Okay, this figure show you the solution based on the several types of forces. Number one, web subjected to axial force only. Same goes to the bolted connection. There is several types of the analysis for the bolted connection. It is under direct shear force or moment, outplane moment, or another one is in-plane moment. Same goes to the welded connection. It's different analysis with bolted and welded connection. Why? Of course, the different material. One for the bolted, another one for the welded connection. Okay, now we can focus next how we want to design the welded connection based on the axial force only. Okay, the first of all, we can assume P meant for forces, axial forces, axial force, P. In this case, number one, assume P equivalent to LE1, effective length 1, plus LE2 for effective length 2, based on the figure. If there is LE3, so we need to plus again LE3. But in this case, there is only LE1 and LE2. And then based on the moment, forces or force times distance, we can have a datum AA to analyze how we calculate the value of P and L and so LE and so on. Okay, based on the moment at datum AA, we can have the formula for PB, P times B. P times B, can you jot this down or take note for that? P times D is not PB. It will be confusing if we put PB. PB is something different from other topics. It's not the same for the PB from the other topics. Now, please take note that P times B for the moment, analysis for the moment datum at AA. P times B is equivalent to LE1 times A plus B times A plus B. That's a distance, showing you the P times B at the moment datum at AA. So you can carry on that based on the equation. So you can find the LE1 and LE2 based on this moment at atom AA. For example, or next, LE times A plus B. Okay, therefore, based on the equation, B over A plus B, this is the overall distances given you the section A plus B, the distance, length of the or width of this section given to you, equivalent to LE 1 over P, equal to, so you need to elaborate more, LE 1 divided by LE1 plus LE2. And if you take about A, then you need to ratio again A plus B equal to LE2 divided by total LE1 plus LE2. Okay, let us make an example. For this example, we call it example 5. Determine the wet length if only side welding is applied on the connection as depicted below. If, again, determine wet length if only side welding is applied on the connection as depicted below. Okay, given to you the size of this section, here, oh sorry, (65 times 50 times F is the thickness, L is the symbol for the section, single angle section. We can call this unequal single angle section because the size is not the same, 65 and 50. 65 and 50. So we can call that unequal single angle section. Okay. Can you refer to the table of properties now? Under unequal angle, the size of the unequal angle given to you, then you need to refer for this section only. That is 65 times 50 times 5 for the thickness of the single angle section, unequal single angle section. Can you refer that now? And can you give the value of the you can also see when you open the this table, on the top of the table they provide you the radius of gyration, YY for the major axis, ZZ for, or ZZ for the minor axis, and another one is for the UU axis and BB axis. Can you find that? Can you respond now? Can you refer and tell me what is the value of the CY? value of the CY.
$1.99.
The units, can you tell the unit?
CM.
Can you convert to the mm? What is the value in unit? The value of the unit millimeter is 19.9. Am I right? 19.9. Can you refer to the given figure in the problem, example 5? B is equivalent to 19.9 millimeter, showing that that is the CY value for this section. CY value means the distance between from the bottom to the centroid of the single angle section, or of the, again, CY is meant for the distance from the bottom of the unequal single angle section up to the centroid. Can you got it? Can you follow me? Can you get it? Value of B. Everybody? I don't want to continue if there is no response from you. No, Aina. Okay. Thank you. So how about A? How about A? How to get the value of A? Clark, can you speak? Can you tell me how to get the value of A? You can open the speaker and please tell me now how you get the value of A from the section given. Come on. Muhammad Amit, can you tell me how to get the value of A? Muhammad Amit.
Kejap je tu. Tengah cari.
Sorry. 65 given the unequal angle section in your cases, in your example 5. Now, how to get the value of A? 65 minus CY. 65 minus CY. Okay, you can get the answer of the 45.1. The balance from the CY, from the 65 width. Sorry. Okay, next. Okay, from the example, you need to calculate the design load, or P, equivalent to 1.35 GK plus 1.5 QK, equivalent to 50 GK times 1.35 factored, and QK 60 times 1.5 factored, equal to 157.5 kilonewton. Okay, for the next, we have to know the LE, or overall sizing, LE, and L1. Overall sizing, LE and L1. Okay, so this is under the axial force only. Axial force only. Okay, next, overall sizing, how to analyze it. Let's use 6 millimeter. If there is no given to you for S lead length, so you can assume lead length S is equivalent to 6 millimeter. And then for the effective throat thickness A, equivalent to 0.7 S. Okay, you can straight away get the answer for the A, 4.2 millimeter. Now, you can have the design of resistance, FWRD, equivalent to FVWD times A. FVWD times A is equivalent to 234 times 4.2. 234 is from here. 234 is from here. If your steel grade S275, FU equivalent to 430, and FVWD equivalent to 234 Newton per millimeter square if the thickness of weaker jointed part is less than 40 millimeter. Straight away, can have the value of here, 234. Now you can convert to the kilonewton per millimeter run. Is equal to 0.983. 0.983. So therefore, LE is equal to P over FWRD equal to 157.5 divided by 0.983. You can have the value of the LE is equal to 160.2 millimeter. And then for the detail sizing, LE is the total. It's the total of LE1 plus LE2 plus TW, where TW is the overall depth of the angle section. The overall depth of the angle section. Now, by using moment, take moment at datum AA as we discussed just now, based on the moment at datum AA, we can have this equation, LE times B equivalent to LE1 times A plus B plus TW times A plus divided by 2. This is based on this datum, AA. We can have this formula, moment at datum AA, and then you can find other value if you have the total LE based on the moment at datum AA, where LE1 is equivalent to 16.5 millimeter. You can double check after this class. This is for the non-face-to-face practical. You have to practice after this class. (16.5 millimeter). Now we can have another LE2 value from from the same question. From the same equation. Can have LE2 equivalent to LE minus TW minus LE1 equal to 78.7 millimeter. Now, you can have another thing is total length L1 and total length L2 for the applied weld length with end turning. This is for the final value of the L. After you find the effective length, you have to give to the welder that the man who want to weld the jointed, the welding jointed. Okay. Now, what is the value for that? L1 and L2. L1 is equivalent to LE1 plus S, and L2 is equivalent to LE2 plus S. You remember that. Okay. This is under axial force only. Give you the answer of 22.5 millimeter exactly, but when you want to give to the welder for the welding process, you need to give them not the exact value, but for example, the exact value you have 22.5, then give to them 30 millimeter apply weld length 30 millimeter. Cannot give you the exact value. How to welding the exact value 22.5 millimeter. It's not practical. So you give them the 30 millimeter answer. Same goes to the L2, 84.7 millimeter. So you apply 90 millimeter. Any question before we take a break? 5 minutes. Have a drink first. Any question? No question? Okay, take 5. Maybe continue at maybe 9:18. Take 5. Okay, we can continue with another two example. Another two example. Is it okay? Are you ready? Please respond. Are you ready?
Yes.
Okay. Next, we are subjected to in-plane moment and out-of-plane moment. Okay. Similar to bolted connection. Similar to the bolt design, the stresses to be checked are the direction and stress to the eccentric moment. Therefore, the general expression used in both cases are FVED equal to P over summation of LE, and V meant for shear, F meant for tension or torsion. ED is equivalent to PE. PE meant for moment, P times E times R max over summation of IY, summation of IZ. And the resultant force between FVED and FTRD given to you, this formula, the cert for or FVED square plus FTED square minus 2FED, 2FVED times FTED cos theta. This is for the Armax hypotenuse. Armax hypotenuse. Okay, this Armax hypotenuse. Okay, I think this is, in this, we already discussed on under the bolted connection. I will go straight away to the example, I think. To this example. Okay, we have 6 and 7. Okay, we have 6. Okay, this example 6, example 6, given to you the figure, determine the appropriate weld size for the connection shown below. Okay, always remember E is the distance between the centroid to the design load, or the of the point load, or the design load. 150. Design load here is 400 kilonewton. From the centroid E 150 millimeter to the P design load. Okay, so there is two faces or two surface for these cases, for this bracket. Then P is pointed at the or design load at the point between two surface. Between two surface. That's why we need to calculate P is equivalent to divide by 2. 400 divided by 2, 200. And then next design load is 200 P. Next, direct shear force, FVED, is equivalent to P over summation of LE, 200 divided by 300 plus 2 times 160, equivalent to 0.323 kilonewton per millimeter. Assumption here is the weld thickness is 1 millimeter per run to ease the calculation. Consider only one plate. Summation of A, 1 millimeter run times length 300 plus 2 times 150 means bottom and top. 160 bottom and top, the welded length times 2 bottom and top, and the sided at the side 300 millimeter length. The total for this A, summation A is to 620 millimeter square. Okay, So you need to find the Y bar as well, equivalent to 2 times 160 times 1 millimeter run times 80 times 80 times 80 is the 160 divided by 2. Divide by 2. Okay, over 620 millimeter square give to you the Y bar for 41.3 millimeter from left. Okay, now you can calculate the IY and IZ based on the Y bar and so on. Okay, IY equivalent to BH cosine BH cube divided by 12 plus 2 times 160 times 150 square. Give to you the answer 9.45 times 10 power of 6 millimeter power of 4. Same goes to Isaac. This also you need to practice after this class. 1.43, please double check. 1.43 times 10 power of 6 millimeter 4. Okay, next, Armax based on hypotenuse. 160 minus Y bar from the left. Square plus 150 square give to you the answer of Armax 191.3 millimeter. 191.3 millimeter. So that FTED equal to P times E moment, P times E moment times Armax divided by summation of IY plus summation of IZ, which is already calculated to you. And then you just include the value in the equation. Then you can have the value of FTED 0.664 kilonewton per millimeter. Then the resultant force based on this FVED and FTED, you can have the resultant force ED from the vector sum 0.90 kilonewton per millimeter. And the sizing, we can have PL equivalent to FR 0.9 kilonewton per millimeter run. If we can have the S value 5.52, then you can answer the applied 6 millimeter fillet well. Any questions so far? Before the last example, 7. Before the last example, 7. Okay, there is no question so far. Okay, the last example for today, example 7, another type of the moment for welded connection. Determine whether the connection shown below is safe to be used. Okay. Design load as usual. Total wet length LE, F, F meant for flange, 173.2 given to you, minus 2 times 8, both sided, top and bottom, for the for this equation. Flange and web. Web. It's not web. Web. Flange and web. 280 web minus 2 times 8. Both side. Both side. 8 millimeter gives you 8 millimeter grade 35 welding. So both side 2 times 8. LEF 157.2 millimeter and LEW 264 millimeter. Therefore, LE is equivalent to times time 157.2 plus 264 give to you the answer. Y2 because of the both side 842.4 millimeter. And then calculate for the direct shear force FEED P over summation of LE 273 divided by 842.4 gives the answer of 0.324 kilonewton per millimeter. Then shear force due to up of plane moment, assume the thickness of the weld is 1 millimeter to ease the calculation. IY is equivalent to 2 times BH3 over 12 plus 157.2 times 364 divided by 2 square gives the answer of IY 13.48 times 10 power of 6 millimeter 4. So Rmax is not hypotenuse. Straightforward 6374 divided by 2, 182 millimeter. Then we can have the FTED PE P times E times Rmax divided by summation of IY. The answer is 0.770 kilonewton per millimeter run. So vector sum for resistance force ED is equivalent to FVED square plus FTED square cert. Give the answer of 0.835 kilonewton per millimeter run. And the last one, the sizing PL equal to FR equal to 0.835 kilonewton per millimeter square equivalent to 6.163 S, 6.163 S. Then S is equivalent to 5.12 millimeter. Then the answer for this fillet weld size is 8 millimeter is sufficient. Okay, 8 millimeter fillet weld for resistance of the actual S is 5.142 is sufficient. Any questions so far? Actually, it's the end of the class. Any question before we ended the class? No? No question? Ke dah tiduran semua? Ada question tak? Tak ada Okay, thank you. Hopefully physically on Monday. Okay, sorry for this unexpected ni. Saya tak apa sihat kerana kaki sakit ni. Okay, Assalamualaikum warahmatullahi wabarakatuh. Dan jumpa lagi minggu depan insyaAllah. Terima kasih semua.